Good morning, everyone. This is Mr. Harshika AV, Assistant Professor of Department AID and DS, subject code AL3451, Machine Learning under the Regulation 2021. In Unit 4 of Machine Learning, we will study neural networks and various techniques used to improve the performance of deep learning models. Today we will discuss the important concepts such as ReLU, activation function, batch normalization, dropout regularization, and hyperparameter tuning. ReLU, rectified linear unit, commonly called ReLU, is one of the most popular activation functions used in deep learning. The ReLU function outputs the input value directly when it is positive. If the input value is negative, the output becomes zero. Because of its simplicity and efficiency, ReLU is widely used in hidden layers of deep neural networks. Why ReLU is used? ReLU is preferred because it helps overcome the vanishing gradient problem that occurs in deep networks. This allows neural networks to train much faster. Another advantage is that ReLU introduces sparsity into the network, meaning only some neurons become active at a time. This reduces computational complexity and improves performance. Next, batch normalization. Batch normalization is a technique applied between layers of a neural network. Its purpose is to standardize the input values of each layer by maintaining a mean of 0 and a variance of 1 for every mini batch. This helps the network learn more efficiently and improves the stability of training. Why batch normalization is used? During training, the distribution of data entering each layer changes continuously. This phenomenon is called internal covariate shift. Batch normalization reduces this problem, allowing the use of higher learning rates. It stabilizes the model and also provides a slightly regularization effort which improves generalization. Next, dropout. Dropout is a regularization technique used to prevent overfitting. During training, a certain percentage of neurons, usually between 20 and 50 percentage, are randomly ignored or switched off. This forces the network to learn more general features rather than depending too heavily on a few neurons. Why dropout is used? Dropout helps prevent co-adaptation among neurons. By randomly disabling neurons during training, the model becomes more robust and performs better on unseen data. It is important to note that dropout is used only during training and is disabled during the testing or inference phases. Next, regularization. Regularization refers to a group of mathematical techniques used to prevent overfitting. When a model becomes too complex, it may memorize the training data and perform poorly on new data. Regularization introduces a penalty term into the loss function, encouraging the model to maintain smaller and simpler weights. The first is L1 regularization, also known as lasso regularization. The second is L2 regularization, commonly called ridge regularization. Both methods help reduce overfitting and improve the ability to the model to generalize to new data. Why regularization is used? Regularization prevents the network from memorizing noise and unnecessary details present in the training data. Next, hyperparameter tuning. Hyperparameter tuning is a process of selecting the best values for the parameters that control the learning process of a neural network. Unlike weights and bias, hyperparameters are set before training begins and are not learned automatically. Some of the common hyperparameters: learning rate, number of hidden layers, number of neurons, batch size, dropout rates, and activation functions. Thank you.